comment cell to help you up with the exercise you have, with the exercise I gave you in Blackboard. So this is how it goes. This is the presentation I submitted, okay, done by teacher Guillermo. And in here there is the first example we're going to use. As you can see, the slides also include some description and some screenshots, so it is a good idea to use them as reference. Now, for example, let's work with this example number 1. So in this slide we have this problem. We have a table of information here. This table shows the time in seconds, which is this column, needed by a BMW to achieve this speed in miles per hour. Now, in this problem, I am being given a couple of models. Okay, T1, this is a logarithmic model, and T2, that's a quadratic model. And they're asking me to get on my own a linear model and an exponential model for these pieces of information. So that's what we're going to do. Something important to notice in here is that the problems are usually backwards, like t is usually my x, right, my independent variable, because things depend on time. In this case, it's not that the time depends on speed. Actually, time depends on nothing. But this is just the way the problem was measured. I have a clock in the watch in the hand, and I was measuring how much time did I take to attain these speeds. So right now this is treating the speed as the independent variable and t is the dependent variable. That's why you see the models with the variable as s, which is speed. Okay, but that's just the way in which the problem was measured. So let's start by dumping this information into Excel. So this is speed and this is time. Speed starts at 30, and from 10 to 10 it reaches 90 miles per hour. Now in the case of time, time starts at 3.4, then it jumps to 5, then 7, then 9.3 seconds, then I have 12, then I have 15.8, and finally I have 20. Right? There you go. So this is something that I told you in the exercise from yesterday. We're going to make some adjustment because Excel actually does the regression by trying to find the y-intercept of the point, and if the values are way too shifted, then that's going to cause some trouble to the model itself. So in this case, these are my x's, and I really don't want my x to start at 30. I want each one of these to represent one point in my plot. So what I will do is insert an extra column. In here I'm going to use x, and then I'll force each one of these values into x's that are easier to handle. So I'll be dividing this by 10, so this would get me 3, and then I just subtract 2, so the first value starts at 1, and then each one of them is consecutive. That's going to make my graph like cleaner. It's not that the graph is going to look bad if I have these values, but the model, I may cause some trouble to the model. So it's just easier to do it this way, okay? So now once this is done, I simply select the data. This is pretty simple. I go to insert. You remember the option. Here in the plots, I need to find a plot that says scatter. This is XY scatter, and then I insert it. Now it's simple to see in the points how this is actually an exponential model, because the points are slightly increasing. Now it could also be quadratic, of course, but that's kind of cheating because anything could be polynomial. Now what I'm being asked is to adjust it to a linear model and to an exponential model. So let's just start with the linear model, okay? I just right click one of the points and then find the option that says add trend line, and here in the trend line options I have the linear option. As you can see, here is the line. You can see how the line tries to better adjust to the points. It of course is not that good, okay? I have a bunch of points which are actually separated from the line, but that's the best the line can do. So I'll also select the option show the equation, okay, because I'll use this equation later on. I am actually going to increase the font size of this equation so I can see it easily. Alright, So here it is, the equation. I am going to write down the model over here. That's y equals 2.7286x minus 0.5571. So that's the linear model. Awesome. Now I will use the same tool to find the exponential model. So I'll just select the plot. And here in the trend line, I am going to swap this linear model by an exponential model. And as you can see, now the exponential is a better fit. Okay, the points are closer. It's still not perfect, of course, because these points are almost random. They are really unpredictable sometimes, but the model is quite good. I say the model is predicting the points real well. So I am going to write down the exponential model right here. So this is y equals 2.7549e elevated to them 0.2913x. Now, something interesting to see here is that most of the tools that do regression, for example Excel, whenever you ask for an exponential model, you're going to see the exponential model in terms of e. But that's simply because I have a number here at the exponent, so this is actually e elevated to this number, and if I make that operation 2.71 elevated to this thing, then I am going to have a different value. In this case, that value is actually less than 2. So that is actually the base of the model. X is simply the exponent, right? So that's it. That's how I have the two models. Clearly, the exponential model is a better fit. So now what they're asking us to do, well, we already did this. Okay, this is the examples. Now here they're asking me to use a grapher to see the two models in a separated sketch. So let's just do it. I do not have a grapher here, so I am actually going to be using Desmos grapher. Okay, Desmos grapher, and well, this is an exercise I run before, so I am just going to overwrite this with the new expressions I have. So this is the first equation. These are actually pretty similar. It's a pretty similar run. So this is the first equation, which is the line in red. Okay, and then I have the second equation in here. This second equation, where is it? I'll just copy the second equation, and I'll place that second equation in here. I'll need to fix the exponents, so let me do it. I'll just move this exponent all the way here. So this is the second model, the blue line that represents the exponential equation. Now, as you can see, these two graphs are really close in this area. This area is actually the area in which I have the points. These are the points that I was measured. Well, I was given the points that were measured at a certain time. So during these points, where those points are close together, you can see how the two models are actually good fits. However, before those points, and especially after those points, the models really start to being quite separated, and the differences are huge in here. As much as I continue moving in the x-axis, which is the miles per hour, you see how these two models start to separate even more. So in this exercise, we do not have a question in which they're asking me to predict some value, but I am just going to invent something of that kind, something similar to what you're being asked in the other exercises. So for example, in this one, imagine I ask you find out the time needed to reach, I don't know, 110 miles per hour, for example. So they're asking me to use my model to predict different values in the future. Okay, in this case that's 110. So I'm going to do it with both models, linear and exponential, even though I know the exponential model is actually a better fit. Okay, I'll do it in both to see the differences. So for the linear, I am just going to insert the equation 2.7286 times the miles. Now in this case the miles are 110, but I am not going to use that value because if you remember, my model was fit to these consecutive values. So 110 is actually going to be 9 because 100 will be 8 and then 110 would be 9. So this is going to be times 9 and then minus 0.5571. And there you go. The model thinks I'll reach that speed by 24 seconds. Okay. Now let's try with the second model. In the second model, I have 2.7549 times. Now for the exponential function in Excel, you use exp. Exp means e elevated to whatever argument you have here. So right now my argument is going to be 0.2913 times x, which in this case is again going to be 9 because of the fitting to my model. Okay, so times 9, and the exponential model thinks I will reach that value by 37 seconds. Now we can see that, of course, in the grapher. Okay, 9 here, this is 9, which would be 110 miles. You can see how the linear reaches this in around 24 seconds, while the exponential is all the way here, closer to 30, okay, which is 37 in this case. So that's how the two different models are actually predicting the value. Okay, guys. Now, what you are going to deliver in the two exercises I gave you is an Excel document. My recommendation to you is solve each exercise in a different sheet. Okay. So at the end you just submit one document, and that's it. If you're asked some questions, you can answer the questions directly in the Excel in one of the cells. If they're asking you to, for example, show these kind of things like in a grapher, what you can do is just take a screenshot of this and paste it in Excel directly. And at the end, that's the document you have to submit. Okay, kiddos? I hope this works, and I hope you don't have issues solving this exercise. Remember, the link for this exercise is going to be up until 8 p.m. Okay, guys? So good luck.